they are already published, but I mean, for a further presentation in the graduate level.
Thank you. Okay. So I have selected this article, blockchain-based access control approaches. So it was published in 2021 in IEEE International Conference on Cybersecurity and Cloud Computing. Uh, yeah, so these are the different persons who are associated with this article. So the purpose is, or selecting this article is just to review the different access control mechanisms which are based on blockchain technology. So on the basis of this article and some other articles, I think I will be able to find some new method for implementing ACLs uh, based on blockchain technology. And I'm also considering CKP technology to integrate it with ACL and blockchain. But the target is that the ACL should be low in cost in terms of computation and processing when we are talking it to connect it with the blockchain. So the idea is basically behind the ACLs, they are used to provide controlled access to different resources. And for this purpose, there are different mechanisms, and one of the mechanism is basically ACL. So ACL is basically it is seen and implemented in so many scenarios, like uh, our operating systems, firewalls, etc., etc. But in case of traditional ACLs, usually they are implemented on servers, which basically results in the concept of a single point of failure. So if the server goes down, so we cannot, I mean, the user cannot connect with the resources. Then the other problem is this, that all the users, they have to trust on the third party who is basically managing the ACL policies. So in this case, there is a high chance of leakage of user privacy. Then in some cases where the data generation is very high, just like IoTs, in that case, if we are opting a centralized approach for ACL controls, then there is a very high chance uh, that the server might be, its performance might be compromised. But if we talk about the decentralized approaches, just like which are based on blockchain technology, so these type of issues can be resolved. So access control basically it ensures that data can only be accessed by authorized user to guarantee data security and privacy. So this is the basic purpose of ACLs. So as I told this, the ACLs are very important. So they are basically implemented almost everywhere. I mean, when we have a, I mean, smart card or the digital card which we have in our smartphones, so we just scan it on the door, and then the door opens and we can get in, but we cannot get in all, I mean, we cannot get in everywhere in the gist. So this is basically the ACL which is basically working behind this all mechanism. So similarly, we log in into for suppose your Google network, but we cannot access all the resources of Google network. So there are some users can access some sources, and some other user can access some different resources. So this is all based on access controls. So with simple terms, I mean, in access control list, subject, objects, resource owners, resource, and managers. So these are the different terms which are used in ACLs. So subject is basically, it might be a person, it user that want to gain access to some resource. So objects are usually the resources for what they might be the devices, they might be the files, etc., and etc. The object owner is usually called the resource owner, who is basically have the right to grant or revoke access. So it's just like, for suppose, um, we put our data on the, for suppose, Slack or some social network platforms, then we have the right to grant access to somebody, or we can also have the right not to grant access to some people. So, the managers usually refer to the authorized service center, which formulates and manages access control lists. So this is, I'm for suppose, if we are talking about the GIST, so we can say the GIST safety department or the security department is basically responsible for managing all this formulation of access control policies. So with respect to the blockchain benefits, I think the combination of the blockchain and ACLs, they may address the traditional issues which are present in ACLs. So it is regarded as a trusted public ledger in an untrusted environment, in which the participating nodes jointly determines the contents of the block following a agreed rule, which is called basically a consensus mechanism. So it is basically the consensus mechanism which basically stops tampering and forgery of data. So in addition to all that, the computing power and storage capacity of participating nodes can also be utilized to realize the decentralized data processing. So these characteristics can, I think, can meet the access control scenarios as it is as decentralized policy storage and request to access the resources. So most of us basically know all these things, but still, I think we can discuss it in a few minutes. So we know what is a blockchain. It's basically a decentralized, distributed, and immutable digital ledger. It is used to record transaction across network of computers, ensuring security, transparency, and data integrity. So it is basically a group of data blocks which are chained together using some cryptographic techniques, so just I mean hashing. So the blockchain is basically is realized state machine replication. I mean the same protocol basically it's replicated on different machines, and the different machines are basically working together to agree upon some transaction or some action or some event. So uh, yes, so there are two other things with respect to blockchain. So the one is basically um, mm, the number of transactions per unit time, and how much time is taken by the one transaction. So these two parameters or the metrics are very important with respect to blockchain technology, that um, how the blockchain is basically used in solving some problem. So these two parameters are very critical. In addition to these two parameters, then blockchain is also meets some properties which are very important. So the number one is consistency, and the second one is liveness. So consistency means so that all the nodes should be agreed upon a common view of the blockchain or block, which is going to be added on the blockchain. And the second one is basically liveness. Liveness, this which means basically the transaction which is requested to be processed, it will be processed. It will not. I mean, it will not go to in a stagnant position. Rather, it will be processed after some time. The time might be little bit greater or smaller, but definitely the transaction will be processed in. Uh, the block has two parts, basically the block body and the block header. So the transactions are basically arranged in body part, whereas the header part contains the vertical hashery of the multiple transactions in the block and the hash of the previous block and the nonce. So the technology basically which we are presently using is basically the Bitcoin based and the Ethereum based. So presently, smart contracts is one of the most popular technology which is used to implement blockchain concepts. In case of Bitcoin, the programming is a little bit, I mean, less flexible uh, because it is not complete programming language, which is called not Turing complete. Whereas in case of Ethereum, it is Turing complete, which provides a complete set of programming constructs which can be used to implement complex logics. So the different kinds of blockchains for access control mechanisms uh, are given in this paper are basically proof of work based blockchains, proof of stake based blockchains, single committee based blockchain, and sharding blockchain. So these are the different types of blockchains which can be used to implement access control mechanisms. So we will see them one by one. So in case of proof of work based, I mean, if we want to implement ACEs using proof of work based blockchain, so then in this case, uh, the nodes they have to mine mine a block, and which is called basically a mining process, in which basically the nodes are given a mathematical puzzle, and the node which solves that puzzle first, that node is basically have the right to add its block into the blockchain. So in this case, there are, because it's a survey paper, so they have uh, revealed these two researches, which are basically using proof of work based blockchains to implement ACLs. Then the other approach, which is basically disclosed in this paper, is basically proof of stake based blockchains, which can also be used to implement access control lists. So in this case, the nodes they don't compete for the computation or processing. Rather, the nodes which have higher stake, they have the high probability to mine the block. So again, but in this case, there are some issues which are basically some vulnerabilities. The three which are basically I see in this paper is nothing at stake attack, grinding, and long range attack. So these are the different attacks which are basically specifically associated with proof of, POS based blockchains, and basically they are not associated with proof of work based blockchains. So we can see these attacks basically nothing at stake. It's just like a double spending attack. So we will not go into the details of double spending attacks. So it's basically where the attacker try to spend uh, its stake, or let's suppose coin or token for two times. In case of long range attack, the attacker basically it try to fork the blockchain from the Genesis block in order to create a blockchain in favor of himself. So, and similarly, in case of grinding attack, uh, it is also basically one of the vulnerability in POS-based blockchain where the validator manipulates randomness to select themselves as the leader for future blocks by repeatedly grinding or iterating through possible data inputs. So in this case, the attackers they try to guess the data and they keep on guessing and trying uh, to create to guess the possible next block. So then there are some other blockchains which are basically single committee based. These can also be used to implement the ACLs, and I observe this is one of the good option to implement ACLs on blockchain where there are high chances of attackers or malicious nodes or malicious users. So in this case, a group of nodes or a group of users, they combine to form a single committee, and they run a Byzantine fault tolerance consensus mechanism. And in case of uh, in case of a single committee based mechanism, so they can use permissionless protocol like POW or PUS for the selection of the committee members. And they can also use permission-based protocols, just like a centralized authority for authentication purposes. So these protocols, these these two types of protocols can be used to select the committee member. The key challenges here is basically the member selection problem, because if the number of nodes grow, so then the complexity of communication between those nodes will also grow. So, yes, so uh, we try our level best to keep the limits to order n, but as n is basically a number of users, so if it grows, the communication between different nodes will also grow, which is not a good in case of basically decentralized communication because the nodes are very far away from one another. Then there are, because it's basically BFT mechanisms, the nodes they have to exchange their votes with one another. So this is also causes a high communication cost on the network. So these are some issues with this technology, but at the same time, it provides a strong consistency because all the nodes are directly communicating and exchanging their votes with one another. Then the other type of blockchain technology, which is basically disclosed in this article, is basically a sharding blockchain. So they can also be used to implement access control lists, but they are little bit, uh, different mechanisms. In this case, basically, The different nodes they are basically grouped together to make a shard, and which is called basically group. So the different group of nodes basically they can be used to solve some specific problem. Probably one group uh, can be used to store or upload the policies. The other group may be used to process the requests, etc., and etc. So, but this is also one of the good technology. Before reading this paper, I basically didn't know this technology. So it's first time I just see this technology through this paper. As for the types of ACL models are concerned, so we have role-based access control mechanisms, attribute-based access control mechanisms, ID-based access control mechanisms, and history-based access control mechanisms. So it's interesting. I knew role-based access control mechanisms, attributes access control mechanism, ID. I know mandatory access control mechanism, but interestingly, this is new to me, history-based access control mechanisms. Let's see one by one what are. Yeah. Mm. So yes, role-based access control mechanisms are basically the one when where we have multiple users or the subjects and multiple objects. And at the same time, the subjects are basically assigned different roles, or they are basically grouped together in different roles. So, for suppose if we talk about some university type of organization, so um, the student is a one group, it is one role. The professor is another role, and probably the admin is another role. So these different roles have basically different rights. So this all is basically implemented um, in the ACL. So many to many means one user can have many roles. So for suppose sometimes it is I mean it is very visible here. Like the student, they they are also a part of the student role, and if somebody is working as a researcher, so he or she is also a part of the researcher. So I didn't see, here probably, but in Pakistan, so the student he is also sometimes he is also employed as a research associate. So in that case, he is a student as well as he is a part of the faculty as well. So in that case, he has a right to access the courses uh, grading system. I mean, he can change the attendance and grades as well. Uh, yes, but I think uh, here the students they don't have the right to change their attendance and grade. Definitely not. But when I was in PhD, so I was associated with some professor as a TA, teaching assistant. But at the same time, I have the right to change the grades and attendance of the students of that class. So I mean, this is a mechanism where the multiple users have the multiple roles. Um, but in case of large setups, it becomes quite difficult to store a lot of information when there are so many relationships between resources and the users. The other technique is basically attribute-based access control mechanisms. In this case, basically the access is provided on the basis of some attributes. So the attributes, I mean, it is decided uh, by the department or person who is implementing the ACL, that what type of attributes uh, he or she will consider to provide access to the user. So for suppose, I mean, in some cases, uh, the user they have the right to access some resource using his username or password, but at the same time, sometimes he is also constrained with timing. So I see here we can get into our lab or building at any time. But what if university decides that nobody can enter uh, after 12 p.m. So in this case, basically this type of access control mechanism will be required. We have the user, and we have the card, we have the right to, and we can access, but we can access only before 12 p.m. The other one is basically ID-based access control mechanisms. So it's one of the simplest form of mechanism when we are basically have a username and password and we can get into the system or we can get access to the resources. The other one is basically history-based access control mechanisms. So sometimes probably some of us have observed this history-based access control mechanisms. So in this case, the user can get access into the system, but at the same time, his historical actions are also observed. So one of the example is this. For suppose when we enter username and password, so we have different systems. So when we enter password 4 or 5 times, then system does not allow you to enter your password again uh, for for 12 hours or for 24 hours. So I personally faced this problem with LinkedIn. So he is, I mean, the LinkedIn basically implementing some sort of history-based access control mechanisms. So access control procedure is basically it's very simple. It's not very complicated. So we have subjects who claim to access some object. So if we look into this access control mechanism, so there is some management institution which is basically in this. I mean, if we talk about our university, so IT department or some security department, safety department. So this is basically this area. This is just a storage institution which stores the policies uh, in the database, or we can call it a access control list or access control database. So subject basically it requests for the access mechanism to this centralized institution. In this case, it is centralized, and then it will inquire. It will inquire from the storage institution that whether the person has the right to access the requested resource or not. And then the grant permission or not grant, the grant or not to grant will be sent to this person, and then he will be able to get this data from the object. So this is a simple control access mechanism. So in this case, basically we have access control policy upload and storage. This is one of the procedure, and the other one is basically access control request and processing. So these are the two components which are basically working together to implement the access control mechanisms. So in case of a centralized storage institution, um, the institute is basically storing the policies or the rules and regulations of access controls. But in this case, it is simple um, and quick, but at the same time, it is basically vulnerable to a single point failure, and we have to trust on the one entity for that purpose. The other one is decentralized storage mechanisms in which are ACL. I mean, we can store it on some decentralized technologies like the blockchain. Uh, but in the blockchain case, still there are two approaches to store your access control list. So the one is basically uh, direct storage on the block, so we can store our access control matrix, access control list on the block. But if the access control lists are very big in size and they are frequently changing, then I think this approach is not a good approach. And then what we can do, we can store the hashes on the blockchain, and the whole access control list we can store it off chain. So in this case, I think it's one of the good way to use the blockchain technology. As So access control request processing is also basically centralized, and it also be decentralized, as in the case of storage mechanisms. So processing can also be centralized and decentralized. Centralized, we have seen that there might be a single server which can process your request, but at the same time, we can use the blockchain technology as well in the centralized cases. So in the centralized case, uh, we can only put our ACL on the blockchain. The node or the persons who are, or the institution who is basically responsible for giving access to the user. So he is not basically participating in the consensus mechanism. It is just accessing the access control list from the blockchain, and it is just verifying whether the resource requested by the user is valid or not. So basically, it is not participating in the consensus mechanism. So in this case, it is centralized, and the processing is basically still the centralized. The other one is basically decentralized processing, where the institution basically, or the nodes basically participating in the consensus mechanism on the blockchain, and the processing basically, the request processing basically takes place on the blockchain, and multiple nodes they are basically involved in processing the access request. So in this case, because there are multiple nodes which are processing the access request. So even if some nodes are not available, still the system will not suffer from a failure. So this article is basically, it's a good article, very simple, and but conveys a lot of information about the blockchain technology um, and the access control lists. But there are so many things which are written in very abstract manner. So that is why I have to put so many things on the slides. So I personally understand it's a good blockchain. It's a good technology. I mean, for decentralized storage and processing. But at the same time, it requires researchers to have an in-depth understanding associated with the storage and processing, especially when we are basically implementing something on the blockchain. So I personally come to this conclusion that the hybrid approach is comparatively more suitable to implement access control lists on blockchain. The hard part is basically to bring ZKP into the scenario, to integrate it basically between the access control list and the blockchain. So this was my presentation. I hope it was simple, but a little bit long. So I tried to make it a little bit tutorial type, right? So I hope because it is a tutorial type, so I hope there is no more question. But still, if you have any questions, so you can ask.
So your next paper subject is blockchain.
Yeah, yeah, yeah.
Okay, thank you.
Yeah.
Yeah,
Yeah. Uh, I have implemented little bit.
I see.
Yeah. No question.
I understand. All people understand your
Oh, thank you, thank you, thank you.
Good teaching skills.
Uh,
감사합니다.
What is your
이제
opinion?
잘하고요. 질문 아까 안 했어요.